Good morning, everyone. My name is Nagafanindra, and today I am here to present my tech talk on topic electrical quantities such as current, voltage, and energy. So today my topic contains about charge, current, voltage, power, and energy. First of all, before that, what is basic electrical? What are basic electrical quantities? An electrical quantity is the quantity which supports the flow of the electricity. In electrical and electronical circuits, there are five major electrical quantities that are used to analyze the circuits. These quantities are charge, current, voltage, and electric power and energy. So, what is an electric charge? Electric charge is nothing but simply charge. Electric charge and simply charge both are same. It is a property of subatomic particles like protons and electrons. The electric charge is denoted by symbol Q or capital Q or small q and measured in coulombs. One coulomb is given as 98,500 Faradays, like that something. And as per the electron theory of matter, we know that every matter consists of tiny particles called molecules, and molecules in turn are made up of atoms, and atoms consist of three fundamental particles, namely electrons, protons, and neutrons. Positively charged electron is carried out by a proton. Negatively charged electron is carried out by an electron. Neutral, there will be no charge, or these three particles are called the subatomic particles. In the nature, the smallest amount of charge that exists is a charge carried by an electron, which is denoted by E, where it is equal to 1.6 into 10 power of minus 19 coulomb. Though proton also carries a charge of 1.6 into 10 power of minus 19 coulombs, but it's a positive. So the smallest amount of charge is carried by electron in the nature. Electrical charge fundamentals. Two fundamental principles of electric charge. There are two fundamental principles of associated with electrical charge. The quantization of charge. According to this theory, the electric charge can occur as an integral multiple of fundamental charge of electronic charge, which is represented by Q is equals to Ne. Q is given by charge, N is number of electrons, and E is the charge of electron. Law of conservation of charge. According to this law, the electric charge can neither be created nor destroyed. Thus, for a closed system, the electric charge remains as a constant. According to Newton, also the same. The energy can't be destroyed or created. So here is one of the numerical questions. So find the number of electrons in one coulomb charge. As we all know, Q is equals to Ne is the formula, and one electron charge is given by 1.6 into 10 power minus 19. So n, we want to find the number of electrons. So n is equals to Q by E. One that is equals to 1 by 1.6 into 10 power minus 18. That is equals to 6 into 10 power minus 18. So we can say that number of electrons in one coulomb charge is approximately 6 into 10 power of 18. And next, what is an electric current? Electric current is defined as the direct flow of electric charge under an influence of electric field. It is denoted by symbol I, or where I is used to denote a constant electric current, and small I is used to denote a time varying current, where capital I is used for denoting constant current and small I is used for denote the time varying current. Depending on the direction of flow of charge, the electric current may be classified as two types: direct current, the DC current, which is called as direct current, in one which flow in only in one direction, and alternating current. An alternating current AC is one whose magnitude changes continuously and direction also changes periodically. Mathematically, the time rate of flow of electric charge is known as electric current, which is given by I is equals to Q by T. Electric So here is another numerical question. Calculate the electric current in a circuit which has 20 coulombs charge in 5 seconds. And we know that formula is I is equals to Q by T. Given Q is 20 coulombs and T is 5 seconds. So we can easily calculate I is equals to Q by T. This is equals to 20 by 5, and that is 4 amperes. Here current is always measured in amperes. And what is voltage? Voltage is also known as a potential difference. It is the electric pressure which makes the electric charges to flow in a conductor, and the voltage is defined as the work or energy required to move a unit charge from one point to another in electric circuit is denoted by symbol V. And the energy required to move an electron in a particle from in a particular direction, some amount of energy is required, that is called as a voltage energy. So the voltage energy is classified into two types: direct voltage. A direct voltage is one which has constant magnitude and direction with respect to time. Alternating voltage. An alternating voltage is one which changes its polarity in alternating direction with respect to time. Mathematically, it is represented V is equals to W by Q, where W is given by charge. In the circuit below, uh, there are two resistors and one power source. Have resistance, one power source, and one R1 is equals to 5 ohms and R2 is equals to 10 ohms, and the current given directly to R1 resistance is 4 volts, and they asked to calculate the voltage across the same resistor. So using Ohm's law, V is equals to IR or V is equals to RI, we have to know the current passing through the R1. So we know the voltage, we know the resistance, so it is easy to calculate the current. I is equals to V by R, which gives us I is equals to 0.8 amperes. If two resistors are in series, therefore the same current passes through them. Hence, current is I2 through R2 and it is equals to 0.8 amperes. So we now use Ohm's law and find the voltage across resistor 2, which is equals to V is equals to IR, and we just got I2 is equals to 10. I2 is equals to 0.8 and R2's resistance is 10. So I into R is equals to 10 into 0.8, which is 8 volts. Next, what is power? Power is nothing but the rate of doing work in an electric current is called electric power. It is denoted by P, capital P or small p, where capital P is used to represent constant or average power and small p is used to represent instantaneous power. So mathematically, it is represented as power is equals to work done by time, or in terms of Ohm's law we can also write P is equals to I square R. I is current and R is resistance, where W is work done measured in joules and T is time, and thus unit of electric power is given in joules per second. But in practice the SI unit of power is watt, capital W. An electric bulb is connected to a 250 volts generator. The current is 0.05 amperes. What is the power of bulb? Here we have V and I. So we can use power is equals to I square into, we can use power is equals to voltage into current. So P is equals to 220 into 0.05, 22 into 0.5, which is 11 watts. Therefore, the required power to glow the bulb is 11 watts. And what is an electrical energy? And electrical energy is nothing but the ability to do work in electric circuit is known as electrical energy. The electrical energy is defined as the total amount of work done or total energy expanded over a certain period of time in an electric circuit. Electric circuit. Mathematically, it is represented as E is equals to QV and E is equals to power into time, or Q into voltage, where Q is a charge and V is the potential difference, also called as voltage. Mathematically obtained by integrating the electric power over a certain period of time, as W is given by in the integral T1 to T2, PT and dt. Though a source of EMF 15 volts supplies a current of 2 amperes for 6 minutes. How much energy is provided at this time? We know that energy is equal to power into time and power is equal to voltage into current. So voltage is 15 and current is 2 amperes. So energy is equal to V by T, that is equals to 15 into 2 into 6. 6 minutes you can write as 6 into 60 seconds, because the energy is always calculated in joules per second. So we need to convert the minutes into seconds and while we are calculating the energy. So it is so answer is 10,800 watts per second, or 10.8 k kilovolts kilowatts. So conclusion, uh, electrical charge is the most fundamental electrical quantity in an electric current. When this charge flows through a conducting material, it consists of an electric current in the conductor. The factor which pressures the electric charge to flow is the voltage or the potential difference. In addition to the charge, current and voltage, we require two more physical quantities named as power and energy. For practical calculations, power is the rate at which an energy is expanded in a circuit, and while energy is the total amount of work done over a certain period of time in a circuit. So, this is my presentation. Thank you.